Alright, Common Core Algebra 2, another flipped lesson in Chapter 2. This is going to be Section 6. This is going to be about scatter plots and lines of best fit. So we're going to talk about three major topics here. Creating scatter plots, which is going to be really nothing more than just plotting points. And then we're going to determine the correlation. We'll have something called a correlation coefficient. And finally, the last thing is we're going to be determining our line of best fit. So that really is nothing more than writing an equation, which we have done in the past in like 2.4, I think is when we did that. So first piece, a scatter plot, like we said, is a graph of a set of data points. So we're just going to have an x and a y variable, just a series of points. It could be 3, 4, 5, it could be 36. And then we're going to have correlation, and I mentioned correlation coefficient. That just determines how closely the x and y are related, and more importantly, how closely one data point is related to another data point. So the first thing, if we're creating a scatter plot, we're just going to start by plotting each set of points on the xy axis. And if I give you some problems, so we just have alternative fueled vehicles, so that's like hybrid vehicles, all that stuff. And then we've just got a set of data points here. So every x has a y, and we're going to plot each one of those. And it would look something like this. Okay, so after x amount of years since 1997, so you see we're counting by 2's here, 0, 2, 4, 6, 8 years. As those years increase, you'll see that there are more and more cars. And you can see here we just plotted each one of these points in blue here. Okay, and we've got as this is going to be pretty closely related because you see the line is trending similarly. So correlation, like we said, how closely the data points are related, and we're going to have three different types of correlation. Positive correlation means that as x increases, the y also increases, which is basically what we just saw. You see that as we're moving to the right, our points are increasing. Now we could have something called negative correlation, which is just the opposite, that y is going to decrease as x increases. And so as we move to the right, that means x increases. We're moving to the right. You see your points are falling. So that's going to give us negative correlation. No correlation would be that we can't see any sort of relationship between them, that as x increases, y doesn't really seem to follow either route. It doesn't get bigger, it doesn't get smaller, it doesn't increase, it doesn't decrease. And it would look something like this. So as we read the graph from left to right, the points are just kind of going all over the place randomly. We don't really have an idea of how they're related, which means they're not really related. To find, and so that correlation coefficient that we're going to denote with r, so much like slope is m, correlation coefficient is going to be r. You're going to see that in your calculator a lot. And it's going to just tell us how closely the data are related, like we said already, and it's always going to be some value between 1 and negative 1. So really important here, our correlation coefficient is always going to be our value of r between negative 1 and 1. So a positive correlation coefficient like this is going to be an r value close to positive 1 because they look pretty closely related. Now it's probably going to be like 0.75, 0.8, 0.9, somewhere in there. And negative correlation coefficient is going to be an r that's close to a negative 1. Now here, my guess would be r is like maybe negative 0.5. They're closely related, but they're not like really on the same line. We could draw a line that would show them though. And no correlation coefficient is going to be r equal to 0. So really close to 0. So this could be like 0.1, negative 0.1, but really there's no correlation, so we're going to call that r equals 0. Okay, the last piece we're going to talk about then is determine our line of best fit, which is just if the value of r is close to plus or minus 1, so it has a really strong positive correlation or a really strong negative correlation, then we can draw a line that represents the data accurately. Now we're not going to do this if our correlation coefficient is close to 0 because there really is no line of best fit, there really is no trend. But to find our line of best fit when r is close to plus or minus 1, we're going to start by just drawing the scatter plot like we did. We're going to draw a line that represents those points closely, and then we're going to pick 2 points. Now, big thing here is those 2 points don't have to be 2 of our data set points. They just have to be 2 points on the line. So they could be original 2 points, not from the data set. And then finally, we're going to use those 2 points to find the equation of the line. Now, the easiest one to do here is using our point slope form. So to do that, we're going to need that form, and then we're also going to need to remember our slope formula, y2 minus y1 over x2 minus x1. So we're going to do this first, find your slope, and then we're going to take one of those points we chose from 3 and plug it in with the slope we just found. So we need those 2 points to find slope, and then we're going to plug in our slope formula. That would look something like this. So if we look at our graph that we had, there was 2 points. We drew our line. This is from our first example, and you see all these blue points are the data points. We drew the line that fit them. So we've got about the same number of points above the line as we do below the line, and then a couple on them. So we drew our line, and we just found 2 points on that line, 1 300 and 7 550. And we're going to use those 2 points to find the equation. Like we said, first thing we need to do is find our slope. So if I plug in those 2 points, 300 minus 550 over 1 minus 7, I simplify that to negative 250 over negative 6, and then I can simplify that a little bit more. Get rid of my negative signs, divide both of these by 2, and I get 125 over 3. And so once we have our slope, I'm going to take that slope, and it doesn't really matter which point we choose. We can take either one. We're going to have in our slope formula this point. So you see here, for this example, I took my slope and I chose this point. It really wouldn't matter which one. But we get this is the equation of that line of best fit. Okay, so that was really nothing new, that last piece that determined the line of best fit. It was just a matter of finding 2 points and plugging in for our slope and then our point slope form. Really, big thing, you're going to need your TI-83s because we are going to use the calculator to really find that perfect line of best fit. And so the calculator can run an algorithm that will do that for us. So we don't have to kind of guess and all get different lines because we have different points that we start with. So really important that you bring your calculator to class. That's going to help us determine a line of best fit, which is going to give us a perfect correlation or a perfect approximation to our correlation coefficient. So really what we're going to need to focus on then is determining our scatter plots or creating our scatter plots. Okay, we'll see you next time.